This one is rational exponents. It's a bit of a misnomer on the title. It's rational and negative exponents. So this is a review, hopefully, of the properties of exponents. So if I have a to the negative n, that's 1 over a to the n. Similarly, if I have 1 over a to the negative n, that's a to the n. So the negative says I'm in the wrong place. I'm in the top and I should be in the bottom, or vice versa. So you just swap it around. 2 to the negative 4 is 1 over 2 to the 4 is 1 over 16, 2, 4, 8, 16. If you have an entire fraction, like 5/12 to the negative 2, that means everyone's in the wrong position, so you can just make it 12/5 to the 2. That's the easiest thing to do. You could also say, well, that makes it 5 to the negative 2, 12 to the negative 2, so 5 to the negative 2 times 1 over 12 to the negative 2. I'm trying to figure out how to put all the steps in here. 1 over 5 squared times 12 squared over 1, and then you're back here. So I really prefer just to flip it around. If there's a negative on the outside of a fraction's parentheses, just flip the whole business and lose the negative, is what I would do. So if I have a mess of things, say, so 4x to the negative 2, y to the 5, z to the 7, over 8, x cubed, y to the negative 3, z to the 2. What I would do in this case is just do the subtraction like you always have. So the rule is a to the m over a to the n is a to the m minus n. I feel like probably somewhere in your book there's a general exponent rules, but I'll try to find one and upload it as a document for you. So I would do the 4 over 8 separately, and then say I have x to the negative 2 minus 3, y to the 5 minus a negative 3, z to the 7 minus 2, that's 1/2, x to the minus 5, y to the 8, z to the 5, so the y to the 8 and the z to the 5 are in the top because they have positive exponents. The 2 is there in the bottom, and so is the x to the 5th. So that's what I would do. You could go through and change everything that has a negative exponent and put it elsewhere. Okay, so lost my cursor there. So then you would have 4 stays on the top, y to the 5th stays on the top, z to the 7th stays on the top, but the x squared goes down. 8 stays on the bottom, x cubed stays on the bottom, y cubed goes up, z squared stays on the bottom. Then you can factor everything. So 2 times 2, y. Why did I make so many z? Y. X, 2, 2, x, z. Because there's so many things, I'm going to get a different color to mark out. Okay, so 2, there's no y's on the bottom, so the y's all stay on the top. Z. So I end up with 1, 2, 3, 4, 5, 6, 7, 8 y's and 5 z's. A2 and 1, 2, 3, 4, 5 x's. Well, that's the same thing we got before. So kind of whatever makes you feel more comfortable on that one. So that is negative exponents. The reason that's in the rational exponent section is because people get negative and rational exponents way confused all the time. That's one of those things that most people forget every single year and have to relearn every single year. And I think it's because a negative exponent makes a ratio and a rational exponent doesn't. I think that's what's confusing. But anyway, a rational exponent, you know that if you have x, there's an imaginary 1 there, and if you write root x, there's an imaginary 2 there. You need to keep that in mind, okay? So a to the m over n, which can also be written, oh, sorry, I'm getting ahead of myself. This is a to the m with a root in there, so the denominator is the root. The denominator goes on the outside. This can also be written like that, so you can pull the m out. I usually do that because making things giant and then trying to make them small is a little bit harder than making them small then making them big, so roots are kind of easier. Whenever you have a fractional exponent, you can simplify the fraction first. If you have, say, 6 over 3, that really is just squared because you have 6 of them inside. So if I have x to the 6 over 3, then I have 6 a's, and I'm taking a cube root. This root means take out groups of that many. So I have 1, 2 groups of that many that pull out. So I have a times a. So because that 6 is creating groups of that many, and I'm pulling them out, I could have just simplified it to start with, because I'm basically writing down 3 of them and then grouping them by 3's, so it doesn't matter. So if I write, say, 9 to the 1/2, then I have 9 to the 1 with a 2 in there, but that's what we would just normally write like this. It's not, that doesn't have to be written, and that doesn't have to be written. That's the implied, that's the implied. If it's any other number, you have to write it down. In this case, you do not. If I write it like this, then I'm asking for the principal square root. You do not write plus or minus 3, you just write 3. If you have x squared equals 9, and you take it upon yourself to take a root, then you have to do plus or minus. If you are given a root, it's the positive one unless it indicates the negative one. So let's say that I have 25 to the 3/2, say. So that's square root. Write the radical in the 25, there's a 3 up here, and there's a 2 over there. So this is an example. I could cube 25. So and then this square root of this should be 125. Just check my math here. I don't want to pull up the calculator for this. Yeah. So the square root of this, so this would be then the square root of, okay? And again, I didn't need to write that, and I didn't need to write that. But just in keeping with a kind of method, you can always put that one there and that one there. And then remove this if it's a 2, and remove that if it's a 1. To me, the easier thing to do especially when it has a nice square root, is to make that the square root of 25 cubed. That's a little bit easier to manage to me. So that's the way I do it. I'm going to do one other thing that I imagine probably shows up in this. Well, let's mix a couple. I'm going to mix a bunch of things together and make it kind of terrible, okay? So we're going to go with a negative 2/3, and then okay, so I'm going to do this. So now we're dealing with the negative, but let's deal with it right away. So we have 27x to the 9th, 8, z to the 6th, y to the 5th, positive 2/3. Now the negative's gone, so I don't have to think about a million other things. Now that one's set. So I could go through and write, I guess I will, I guess I'll split it instead of writing the whole big giant thing. 27 to the 2/3, x to the 9th to the 2/3, 8 to the 2/3, z to the 6th to the 2/3, y to the 5th to the 2/3. Okay, so you could deal with these numbers the exact same way that we're going to deal with these letters, but you don't necessarily have to. So I could say cube root 27 squared. Cube root of 8 squared. And then exponent rules, remember, say that if you have to the power and then all of that to the power, then these get multiplied. So x to the 9 times 2/3, z to the 6th times 2/3, y to the 5th times 2/3 equals cube root of 27 is 3, you square it, it's 9. Cube root of 8 is 2, square it, 4. 9 divided by 3 is 3 times 2, so that's x to the 6th. Z, 6 over 3 is 2, times 2 is 4, so z to the 4. The y is a little bit funny because that doesn't divide, right? So you have y to the 10/3, which is fine. It's possible that you'll end up needing to write this as y to the something and then times a cube root of y, okay? So let's look at that a minute. I could have written it like this. I could write any number, any power of anything like this. So I'm putting a cube root out there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So groups of 3 come out. And I've got 1 left. So that's y cubed. Come up here. Y cubed. And then I have that 1 cube root of y left. It's possible that you'll need this. Not necessarily, though. You do, again, you just need to be able to go from one to the other. Okay? So that's just a whole mess of stuff. If you can handle one like that, I think you are all set.